Okay, well, welcome back. Again, once we have all three of these conditions met, we're then able to then use the normal model. And again, like it said here, the central limit theorem allows us to use the normal model because these three conditions are met. Now, standard error is something else that we discussed in chapter 18. Often we know only the observed proportion p hat, or the sample standard deviation, S. So of course we just use what we know and we estimate. Now whenever we estimate the standard deviation of the sampling distribution, we call it standard error, or SE, instead of SD, SE of p hat. And then notice this should look very familiar to you. It's p hat q hat divided by n, or your observed proportion, and this is the probability of success of that observed, and then this again is your observed proportion of failure, and that's divided by the number of in your sample trial. So again, if you have categorical, quantitative, so for the sampling mean, y bar, this is what we use here, for the sampling standard deviation, divided by the square root of n, and that's the above standard error for quantitative data. So as the book talks about, please don't confuse the sampling distribution with the distribution of the sample. I mean, say that again 3 times fast. It's really funny. But again, we got to be very careful of that because there's two different things. When you take a sample, you always look at the distribution of those values, usually with a histogram. That is not the sampling distribution. The sampling distribution is the imaginary collection of those values of the statistics and what it might have taken for all of the random samples. We use the sampling distribution model to make statements about how the statistic varies. So then we go on to some problems. This is question 25 from the textbook. And we'll talk about each one of these separately. So we'll first read and then go through each part and then come back and do the next part. There are 4 parts to this problem. And this deals with pregnancy. So it says, assume that the duration of human pregnancies can be described by a normal model with mean of 266 days and a standard deviation of 16 days. What percentage of pregnancies should last between 270 and 288 or 280? So if the mean is at 200 cells, think about it with a normal model here, or think about a normal model. 266 is the mean. Where is 270 and 280? They're above the mean. And what we'll be looking for is, since it's normal, we'll be able to use z-scores to be able to figure that out. In this problem, it tells us that it is described by a normal model. So unlike the previous instances where we had to go through the conditions to see if whether or not we were able to use the normal model, this one actually tells us that we're allowed to. So here's what it looks like. Here's my normal model. Here's the 266. Here's the 270. And this again, we're looking for the distribution that's between, or the area under the curve, between 270 and 280. So we find the z-score of 270 by 270 minus 266. And we subtract those and we divide that with our standard deviation 16. And we get 25%. Likewise, We take 280 subtracted with 266 and divide that by with 16, and we get 0.875. Now, these two numbers we have to then convert into your junior Z chart. So go ahead and look those up. So 0.875 is 0.8092, and 25% is 0.5987. So we then subtract these. This gives us our answer. So then we write our sentence. So according to the normal model, approximately 21.1% of all pregnancies are expected to last between 270 and 280 days. All right, so let's go back to B. B says, at least how many days should the longest 25% of all pregnancies last? So this is looking for, again, look at your normal model. This one is looking for the top 25%. So at least how many days should the longest 25% of all pregnancies last? So again, we're looking for the top 25%. So let's take a look at what that looks like. So here's my picture. There's my 266. Again, this is right here. We don't know what y is. We're going to calculate that. Here's my 25%. So since this is greater than, and again, we had a lot of discussion about this one the first day back. Here's my greater than. That means this right here is 75%. And this is what we look at. Or you can look at the complement of 25 if you think about it that way. And then 75% using my calculator. I just figured that out using my calculator. And I got 0.674 for my z-score. So once we knew my z-score for my 75% here, or the complement of 25%, here's my z-score here. I then substitute in and then solve for y. Because that again is what we're looking for, that value. So you cross multiply, you multiply by 16 and then add the 266 and we get 276.8 days. So then we write this into a sentence. According to the normal model, the longest 25% of pregnancies are expected to last approximately 276.8 days or more. So let's go on to the third part. So it says, suppose a certain obstetrician is currently providing prenatal care to 60 pregnant women. Let y bar represent the mean length of their pregnancies, and according to the CLT, so the central limit theorem, which remember, this tells us normal, so we're going to check to see if we're allowed to use the central limit theorem. And then, so according to the central limit theorem, what's the distribution of the sample mean? Y bar. And then specify the model, the mean, and standard deviation. So again, we have to check to see if we're allowed to use this first. So I'm going to pause here and switch videos. Be right back.